This is the second part of frequency distribution, and we're going to talk about the different types of data. When we talk about the different types of data, we can have discrete data. Discrete data are things that can be counted using the whole numbers. That are counted with whole numbers. So, for example, points in a basketball game. Regular intervals. Intervals using the numbers on the number line. A continuous set of data would be things that don't conform to the numbers on a number line. Okay? So, this would be not counted with regularity. So, for example, times taken to drive to the grocery store. Okay, so the times taken to drive to the grocery store would be something that wouldn't necessarily be like it took one time to go to the grocery store. It took 3 times to go to the grocery store. You say minutes, seconds, milliseconds, things like that. So things that have some sort of in-between possibilities, those would be continuous data. A continuous variable is a variable that's based on measuring smaller and smaller units. So a continuous variable could take the value of smaller and smaller units. Okay, so this would be like time would be a continuous variable. Okay, and so those are the kind of things that we're talking about when we're talking about general data. The normal distribution. The normal distribution is something that we have when we end up with all of the data put together. A normal distribution looks like this. And you can go ahead and draw this in. I can't seem to draw a straight line. Okay, the normal curve looks like this. It would be called the bell curve sometimes, okay? And this is divided into intervals. So this would be the median, or the mean, I'm sorry. This is the mean. And all of the data is arranged along the mean in certain distinct intervals. And what the normal distribution does is it gives us an idea of how the data is spread out. From the mean, if we go to the left, we are talking the mean minus 1 standard deviation. Then we'd go to the mean minus 2 standard deviations. And over here we'd have the mean minus 3 standard deviations. Over here, same thing. So this would be the mean plus 1 standard deviation. This would be the mean plus 2 standard deviations. And this would be the mean plus 3 standard deviations. All right? The data is distributed in a distinct way. We have the normal distribution, and our measures, or our tick marks, are standard deviations, because that is a measure that tells us how far something deviates from the mean of a set of data. Well, when this happens, we start to talk about the empirical rule. Here's what the empirical rule says. 34.1% of the data is going to fit within 1 standard deviation to the left of the mean, and 34.1% of the data is going to fit within 1 standard deviation above the mean. So together, 68.2% of data is within 1 standard deviation of the mean. As we move out from there, this area under the curve becomes smaller, and so this is really 13.6% in here and 13.6% in here. The empirical rule tells us that 95.4% of data is within 2 standard deviations of the mean. As we move out, these next divisions go to the end. Okay, so this is to the end. And this is going to be about 2.15%, and this is about 2.15%. It takes up pretty much the remainder. So 99.7% of data is within 3 standard deviations of the mean. That means that everything fits into this curve in a regular way. What that allows us to do is look at data very, very specifically in these different intervals as it relates to the mean and to the standard deviation. And so if we have an example here that gives us gas stations, this should be 1,000 gas stations. A survey in 2004 of 1,000 U.S. gas stations found that the price charged for a gallon of regular gas could be closely approximated by a normal distribution, with a mean of $1.88, a standard deviation of 20 cents. That ain't happening nowadays, but we're going to do this as an example. So, we want to figure out how many stations charge between $1.48 and $2.28. If we look at our curve for this, if it's truly according to the normal distribution here, as it says, our mean is $1.88. And so when we go out from there, since our standard deviation is 20 cents, if we go one above the mean, this is going to be 2.08. This down here is going to be one below the mean, so this is $1.68. As we move out, we go down up another 20 cents on this side. We go down another 20 cents on this side. We want to figure out how many gas stations that is. If you'll recall from the previous slide, 34.1% fits in here, 34.1% fits in here. This is 13.6, this is 13.6, and here we have 2.15. Here we have 2.15%. All right? The percentages are closely related here. And so when I ask the question, how many gas stations charge between $1.48 and $2.28, that would be $1.48 and $2.28. All we have to do is add up the percentages. And so what happens is we say that between here and here, using the empirical rule, that would be 95.4%. Remember? 95.4% fits within 2 standard deviations. Well, that's what we're dealing with here. Because this is 1 standard deviation, this is 1 standard deviation, this is 2 standard deviations, this is 2 standard deviations. And so as we move out from the middle, we have 1 standard deviation on either side, 2 standard deviations on either side. That's what this is asking. So 95.4%. 95.4% is equal to 0.954 times 1,000 is equal to 954 stations. What about less, and this should be than, less than $2.08? Well, less than $2.08 would give us from here over. If we add up the percentages, we get 68.2 plus 13.6 plus 2.15. I'll just put B down here. 34.1 plus 34.1 plus 13.6 plus 2.15, and all of that together gives us a total of 50%. Think about it. 50% plus 34.1, which would be 84.1%, which is 841 stations. Think about it, guys. If we're at the halfway mark, 50% of the data is below it, 50% of the data is above it. It's all about interpreting these graphs. What about more than $2.28 per gallon? It's going to be 2.15%, and our 2.15% is going to give us 21.5 stations, or 22 stations. The normal distribution is great because it gives us definite percentages that coordinate to these data values. And so that's good for us because we just interpret the graph and use the standard deviation to mark off our intervals. Okay? You're going to go ahead and do the tomatoes example. We will talk about it in class. All right? Thanks for watching, guys. We'll see you next time.